Hey guys, back with the last question for your classwork sample one. So this is question number 4. No, let's actually delete that. So this question has to do with this table, and it's going to ask you for an algebraic equation. So I just want to break down what an algebraic equation is before we get started. So in algebra, which is the math class that you're taking right now, an algebraic equation has a few things in it. One, it has an equal sign. You see this word equation, you see EQUA is pretty much the word equal without the L. So when you see the word equation, think of the word equal, an equal sign. Now, when you have an equal sign, there needs to be two sides of the equal sign because you're telling me that something is equal to another thing. So the easiest equation to show you would be y equals mx plus b. And of course, if you're not familiar with this equation is the slope-intercept equation, meaning that y is equal to the slope, or m, times x plus the y-intercept, which is represented by b. That is for a different lesson though, and we're not actually graphing in this one, but I just wanted to use that to show you what an algebraic equation would look like. Now, for this problem, let's read it together. This problem says that Mr. C likes to run from his home to the school. He uses his iPhone to track the time and distance he travels during his run. The table below shows the data he recorded during yesterday's run to school that he did not make because the COVID-19 prevents him from seeing his wonderful students, which he misses dearly. Yeah, my fiance just laughed in the living room after hearing that. So let's continue. If Mr. C runs for 0 minutes, so imagine this, I did not run at all. I ran for 0 minutes. No time running yet. Still warming up. I'm still stretching. If I run for 0 minutes, how many miles have I ran or has he run? Well, think about it. If I or if anybody runs for 0 minutes, ask yourself in your head, do they run any distances or any miles in this case? Do they run any distance? No. They do not run any distance. They do not run any miles. They do not run any feet. They have not run a centimeter. And they sure as, you know what, have not run any millimeters. So the answer to this is 0 miles. Mr. C has run 0 miles if he's ran for 0 minutes. Makes sense, right? So you should see a blank in your chart for the time. So at 0 minutes, that's how you read a chart, guys. There's the X column, it's the Y column. At 0 minutes, Mr. C has run 0 miles. Let's add that in. I'll show you again. At 0 minutes, Mr. C has run 0 miles. And that's anybody. Anybody at 0 minutes run will run 0 miles. You can't run miles if you don't run at all. But we look at the chart and we see that as my minutes go up by 5, something happens to the amount of miles I have run. So in 5 minutes, apparently I have run 35 miles. After 10 minutes, I have run 70 miles. After 15 minutes, I have run 105 miles. And it goes up to 30 minutes. And you could see that if you take this 5 and add 5, it'll equal this 10, right? So if you add 5 to this 10, you'll get the 15. So after every 5 minutes, I run a certain amount of miles. I want you to think about that and see if you can figure out how many miles I run every 5 minutes. Okay? And I want you to keep thinking about that. Pause while I read question A, where it asks you to write an algebraic equation to model the data Mr. C collected. Explain in words the reasoning you used to choose your equation. So, let's take that equation we worked with before, the slope equation, and apply it to this because we're looking to find the number of miles I run based on the number of minutes that I have run. So if we're looking to find my distance, because I'm going to give you my time always. I'm going to say, yeah, I ran an hour or I ran 45 minutes. I'm going to give you that. But you're looking for the distance that I run, right? Remember, we had to find out how many miles I run after 0 minutes. So we're looking to find the number of miles run. This chart just happens to give you them all. But we're looking to find that number. So if we're looking to find the distance in miles, then we're looking to find y. So we should put y is equal to something. So you need to figure out how to get y based on x. Well, if x is 5 minutes and y is 35 miles, in math, you could take those two numbers and you could divide them. So you would take your miles or your y, and that would be the number that goes first on top of the fraction they use to divide it. So 35 or y goes up top, and then the 5 or the x value goes on the bottom. So to better represent that, it should be y divided by x to figure this out. So if you do 35 divided by 5, you're going to get 7. Let's see if the other ones hold true. Because if you remember that word proportional from the prior lesson, we need these values, these coordinates, each row in the chart to be equal to each other. So if 35 divided by 5 gives me 7, then another one should give me 7. So I'll take 70 and divide that by 10. That's 7. How about one more? I think we'll do one more, see if it adds up, and then we could be good with that, right? If we do 105 divided by 15 on a calculator, you would get 7. So this 7 is our constant rate. What do I mean by that? That means for every 1 minute that we run, so let's say I need you to fill this out. For every 1 minute you run, you go 7 miles. And if you want to visually see it, let's see if it works out up to 5. Insert another row. One more. 1, 2, 3, 4. Okay. So 2, 3, 4. We don't need these. Delete row. So for 1 minute, 7. Plus 7 would be 14. Plus 7 more would be 21. And plus 7 more would be 28. And if we added 7 more to that, it would be 35. So we go 35 miles every 5 minutes. But if you want to reduce that, you need to figure out how many miles we go every 1 minute. So when you write your equation, you do 7x. But why do we do 7x? So if you look at how 7 compares to 1, 14 relates to 2. Like, what could we do with this number to get this number? And for all of these numbers for the minutes, all we have to do is multiply this number times 7. This number times 7. 10 times 7. Even 20 times 7 is 140. So 7 times the x value, or 7 times the number of minutes. We just plug the minutes in here, and that'll figure out how many miles we go. And then the second part of the equation where we need to add or subtract something, the y-intercept, The y-intercept is found when x is 0. So when x is 0 on this chart, the y is 0, meaning that if we graph this line for this equation would intercept or go through the y-axis at the number 0. That being said, we do not need to actually write anything else in this equation. It is simply y equals 7x. 7 times 2 is 14. 7x. 7 times 30 would be 210. So when we have this equation, we need to explain how in words. So explain words the reasoning used to choose this equation. You could just say, if we multiply the number of minutes that Mr. C ran by 7, we can find the number of miles he ran because he runs 7 miles for every minute that he ran. So that would be like the most descriptive answer. You could also say this. You could just say that for every mile that Mr. C runs, he, sorry, see, even I make mistakes. For every minute that Mr. C runs, he runs 7 miles. That's it. This one would be the bare minimum. You need to just explain that for every minute that I run, he runs 7 miles. You could also say this, for every 5 minutes that Mr. C runs, he runs 35 miles. The reason why I do not like this one as opposed or as compared to this one is because you could take the 35 and the 5 and divide them. So this is the most simplified answer. So we're going to go with that for every 1 minute. Now, in the actual problem that you guys are going to do, keep in mind that the unit of distance that is being used will not be miles. It will be meters. So in the individual work you do, make sure you're writing meters. So these are the wordings that I am looking. So for letter A, you need to have an equation like this. You need to have a sentence like either this or this. Use that wording, guys. Just change the numbers and it's not going to be me in the next problem that's running, okay? All right. So I want you to make sure that you have A filled out so that you are ready to do it on your own later. Remember, when you divide, remember that the y is going first and then you divide x into y. Understand that each side of the table is represented by x and y. You need to look out for what word is here and what word is here. These tell you what the units of measurement are. It's either going to be minutes, it's going to be miles, the next one will be meters, so understand that. Okay? Letter B. Letter B is my favorite because it's the easiest. Does the data represent a proportional relationship? Explain your reasoning in words. Well, to be a proportional relationship, each set of coordinates, and yes, I'm calling these coordinates because if we wrote these down, this could be 2, comma 14, 3, comma 21, right? X, comma Y. So if it's a proportional relationship, all of these values, if simplified, would be equal to each other. So I've already done that up here. So 35 divided by 5 equals 7, 70 divided by 10 equals 7, and 105 divided by 15 equals 7. So when I answer this, I'm saying they are all equal to each other. So they must be proportional. So the relationship represented by the data is proportional because each set of coordinates are equivalent to 7 or are equal to 7. Don't say, yeah, because the coordinates are the same. If you say they're the same, I'm just going to say, no, that's not the correct wording that I want, and I'm going to return it to you. I want this wording. So the relationship is proportional because each set of coordinates are equal to 7 or are equal. Don't say they're the same. Also, you could also explain it a different way. The relationship represented by the data is proportional because the equation would pass through the origin because when x is 0, come on class, y is, let's see, let's see, 0. This means the line would pass through the origin. Yes, you must write sentences, and you must write sentences like this. Again, if you write something like, yeah, just go through the origin, I'm going to say, but how do you know? And I'm going to return your paper. If you just say they're the same, I'm going to say, but how? And I'm going to return your paper. So if I see that, I'll know you didn't even watch the video. All right. So these are the two ways to answer B. Proportional means that each value in this table up here is equal. It is. It also means that when x is 0, y is 0, which it is. So it is a proportional relationship. And lastly, let's read letter C. If Mr. C continues running at the pace indicated in your equation, so what do I mean by this? And when you read that, indicated in your equation, well, it means indicate means in or shown by. So your equation shows that Mr. C is running at a pace of 7 miles for every 1 minute, right? 7 miles for every 1 minute. How long will it take him to reach the school, which is 385 miles from his home? Use mathematical reasoning to justify your answer. So this is easy. So you see that's 385 miles from his home, right? That's the distance. Let's make that orange. So distance. And we'll notice that Mr. C continues running at the pace. The pace is 7 minutes per one, I'm sorry, 7 miles per 1 minute. That's the time, right? So we want to figure out at this pace how long it's going to take him to go this distance at this pace or with this time. Every 1 minute he goes 7 miles. So to figure this out, we have to do 385 and divide that by the time or how many miles he goes per 1 minute. So 385, divide that by 7, and it's going to equal, if you did it, 55. 55 what though? So it will take Mr. C 55, 1, 2, 3 minutes to get from from his house to the school if he continued at a pace of 7 miles every 1 minute. That's like the juicy answer. That's the one that will get you 100%, 115%. You could also something like it will take Mr. C 55 minutes to get from his house to the school if he continues his pace. See, this is like the same answer, just I didn't give the pace. I want you to give this pace. Make me know that you understand this problem. So on the next one you do individually, you should say it will take, I think the kid's name is Marvin, blank minutes or blank hours, whatever, to get from his whatever. That's not what's in the next problem. If he continued at a pace of, and then this will be replaced by the pace in the next problem. All right. I hope this question practice helped you. Please look out for the video later this week. That's going to basically be all of classwork sample number 2. And I would like all of you to really do that because that will be one we'll all do together. So we could do that sample together, but before that, we need to get 1, 2, 3, and 4 done for classwork sample 1. And then we're going to need to make sure we're also doing the other portfolio questions. If you fall behind, you will not like what happens. It's going to be a very, very stressful workload if you put this off till later. All right. I hope you guys learned something from this and take care.